Hello GATE aspirants, welcome to part 4 of GATE Classical Mechanics series. Question number 3. An electron is moving with velocity 0.85 c in the same direction as that of moving photon. The relative velocity of the electron with respect to photon is. Now V relative is equal to V1 minus V2 upon 1 minus V1 V2 by c square. Now its velocity is given 0.85 c minus c upon 1 minus 0.85 c into c upon c square. So this is equal to minus 0.15 c upon 1 minus 0.85, which is again 0.15. So this is equal to minus c. So option B is correct. Next question. The Lagrangian of a system with 1 degree of freedom q is given by L is equal to alpha q dot square plus beta q square, where alpha and beta are non-zero constants. If pq denotes the canonical momentum conjugate to q, then which one of the following statement is correct? Now p of q is dou L by dou q dot. So that will be equal to 2 alpha q dot. So PQ is equal to 2 alpha q dot. So option C and D are correct. Now let us calculate dou L by dou Q, which is generalized force. So this is equal to 2 beta Q, which is not equal to 0. This is generalized force. That means it is not a conserved quantity. This L is not a conserved quantity. So option D is correct. PQ is equal to 2 alpha q dot and it is not a conserved quantity. Next question. The relativistic form of Newton's second law of motion is. Now we know P is equal to mv upon under root 1 minus v square by c square. And F is equal to dp by dt. So F is equal to m into, we have v here. So here we have dv by dt upon 1 upon under root 1 minus v square by v square. I am using u into v rule. Plus we have m into v and derivative of this, which is minus half upon 1 upon 1 minus v square by c square. This whole thing raised to 3 by 2 into derivative of this minus v square by c square, which is minus 2v by c square into we have now dv by dt. So from here we can take m dv by dt common and also this 1 upon under root 1 by v square by c square. So in bracket we'll have 1. This minus sign and this half will cancel. Then we have here v square by c square plus we have v square by c square upon 1 minus v square by c square, which can be written as c square minus v square by c square. So this c square will cancel. This is equal to m dv by dt 1 upon under root 1 minus v square by c square, and this is c square minus v square plus v square upon c square minus v square, which is c square upon this. So this is equal to m dv by dt 1 upon under root 1 minus v square by c square, and this can be written as 1 minus v square by c square. So finally we'll get F is equal to m upon 1 minus v square by c square raised to 3 by 2 dv by dt. And it is not matching with any of these answers. Now answer given in the answer key is C, but I am not getting it. So if you can solve it, then put it in the comment section and let me know. According to me, it should be like this: 1 minus v square by c square raised to 3 by 2. Next question. A uniform circular disk of radius r and mass m is rotating with angular speed omega about an axis, passing through its center and inclined at an angle of 60 degrees with respect to its symmetry axis. Then the magnitude of angular momentum of the disk is. So now we have a, consider x, y, z axis first. We have here x, y and z axis. And disk is tilted at an angle of 60 degrees with its symmetry axis. Symmetry axis is z axis. So it is tilted by 60 degrees. So it is something like this. Now, what will be its moment of inertia along all these axes? That we have to calculate. Now, if it is along this axis, what will be moment of inertia? It will be mr square by 2. Here we have mr square by 2 moment of inertia. Along this axis, it will be mr square by 4. Along this axis, it will be mr square by 4. But this omega is along this axis. We have omega here. So let us take components of omega along this x, y and z axis. Now omega y will be 0 because it is not rotating in that direction. It is tilted in this direction. Now what will be omega x and what will be omega z? Now omega z is equal to omega into cos 60 and cos 60 is half. So omega z is equal to omega by 2 and omega x is omega into sin 60 and sin 60 is root 3 by 2. So omega x is root 3 by 2 into omega. Now Lx is Ix omega x, which is equal to mr square by 2. Yeah, the disk is like this only. This omega axis is tilted axis. So we can write it like this. Okay, now Lx is mr square by 4 into root 3 by 2 into omega, which is root 3 by 8 mr square omega. Now Ly is I by omega y, but omega y is 0, so this is 0. And Lz is Iz omega z, which is mr square by 2 into half omega, which is 1 by 4 mr square omega. Now L is equal to magnitude of total angular momentum is Lx square plus Ly square plus Lz square. So this is equal to 3 by 64 mr square omega square plus 1 by 16 mr square omega square and square root of all these things. So this is mr square omega under root 3 by 64 plus 4 by 64, which is root 7 by 8 mr square omega. So option C is correct. Next question. Consider two blocks, small blocks, each of mass m attached to two identical springs. One of the springs is attached to the wall as shown in the figure. The spring constant of each spring is k. The masses slide along the surface and friction is negligible. The frequency of one of the normal modes is. For that we have to calculate total kinetic energy and potential energy. Now total kinetic energy T is equal to half. Let us consider position coordinate of first blocks is x1 and for second it is x2. So this is x1 and x2. So this will be equal to half m x1 dot square plus half m x2 dot square, and potential is equal to half k, displacement is x1, so x1 square plus half k, and here displacement is x2 minus x1, this difference. This is x2 minus x1 square. So we have to separate it out. So v is equal to, we have half k common, in bracket we have x1 square plus x2 square plus x1 square minus 2x1 x2. which can be written as half into k into we have 2x1 square plus x2 square minus x1 x2 minus x2 x1. Now this can be written in matrix form. So in matrix form, kinetic energy is half, we will not consider here. So we have m here. So this is m 0 0 m. And for potential energy, here we have 2 1. So here we have 2k and k and minus k minus k. So minus k minus k. To find out normal modes, we have to consider this matrix. Mod of v minus omega square t, this should be equal to 0. That means potential is 2k. So 2k minus m omega square, here we have minus k and 0, then minus k, then k minus m omega square, this should be equal to 0. So 2k m omega square into k minus m omega square, multiply this. So this is 2k square minus 2k m omega square minus k m omega square minus minus plus m square omega raised to 4 and minus this k square. This is equal to 0. So we have k square. Let me write this term first. We have m square omega raised to 4 here. Then this is minus 3k m omega square and lastly plus k square. This is equal to 0. So omega square is equal to, we will use minus b plus or minus square root of b square minus 4ac upon 2a. So minus b is 3km plus or minus square root of b square, which is 9k square m square minus 4ac, which is m square k square upon 2 into a, so that is 2m square. This is equal to 3km plus or minus, this is 5, so root 5 km upon twice m square. So m can be cancelled throughout and finally we'll get omega. So this will be 3 plus or minus root 5 into upon 2 into k by m. So omega is root of this. So option C is correct. So these were all the questions from classical mechanics part from 2013 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.